Hey guys, I wanted to do a quick video on doing a couple examples of finding domain from a function, just given the equation. It's something that you guys are going to have to do a lot this year. So just wanted to kind of go over a couple different examples and different ways that we can write our domain of our function. All right, so for the video, I'm going to write my answers in both set and interval notation. You guys don't need to do that. You can do either one. That's fine with me. But again, you need to be able to recognize both forms and know what they mean. So, okay. So for the first one, all right, I have a function f of x, which is 3x over x squared plus x minus 6. Okay, and I want to figure out the domain of this function. Okay, so a good kind of hint to do is you need to figure out what your parent function is. All right, and that'll help you kind of narrow down what your domain possibly could be. Okay, so I see that I have a fraction here, so that tells me that my parent function is a rational function. Okay, so anytime I have a rational function, I want to concern myself with the denominator. Okay, I don't want the denominator to come out to be 0. So denominator cannot equal 0. Okay, because again, if I plug anything that makes the denominator 0 in for x, right, I'm going to get a number divided by 0, which isn't going to work. Okay, so I need to figure out exactly what makes the denominator come out to be 0. Okay, so anytime you have a rational function, you want to take that denominator, okay, and you're going to say that it can't come out to be 0, okay, and you're trying to figure out exactly what makes that denominator come out to be 0, okay. So I have a quadratic, so I'm going to factor it. Okay, and then I'm going to solve. So this is telling me that, okay, x can't be negative 3, and x can't be 2. Okay, so those are the two numbers that if I plug into that function, it's not going to work. All right, so now what I want to do is I'm going to write my domain now. So I have the domain of f. Okay, and this is the first one that I'm going to do is in set notation. Okay, so again, I'm going to start with my brackets. So it's the set of all real numbers such that x cannot be negative 3 or x cannot be 2. All right, so that would be an example of how you would write it in set notation. Okay, and then if I'm going to do interval notation, right, I have to write it with the parentheses, right? And I want to make sure that I'm not including negative 3 or 2, right? So you always want to do it from left to right. Okay, which number would you run into first if you started on the left and then made your way to the right? Okay, so the domain of this, right, again, I'm going to start at negative infinity, and then the first number that I'm going to hit is negative 3, right? And then I want to include a open parentheses there because I can't use 3. And then I want to include a union, and then start again at negative 3, and then work my way to the right. Okay, so again, another issue that I'm going to run into is there at 2. So I'm going to go from negative 3 to 2, and then again jump over 2, and then start over again towards infinity. Okay, so both of those notations mean the same thing. They're just written different ways. Okay, so that's whenever you have a rational function, always work with the denominator. Okay, so the second example, I have a function now g of x, okay, and g of x is the square root of 2x minus 1 divided by x squared minus 3x minus 10. Okay, so again, recognize what parent function that you're using. Okay, so again, I see that I have a fraction here. So I have a rational function, okay. Now I also see that I have a square root in the top. And that's going to be important because, again, you can only plug certain numbers into a square root. So that's going to limit what your domain is going to be. Okay, so this is kind of like a two-part one. All right, so the first part that you're going to do, you can do the denominator. All right, so again, I want to make sure that x squared minus 3x minus 10 does not come out to be 0. Okay, so I'm going to factor that. So it'll be x minus 5, x plus 2. All right, and this is saying that x cannot be 5, and x cannot be negative 2. Okay, so that's very similar to what we did on the last one. All right, now the other part is, again, you want to make sure what you're taking the square root of is positive, right? You can't take the square root of a negative number. Okay, so whenever you have a radical, or a square root in this case, you want to make sure what's inside the square root is going to be positive. Okay, so you want to make sure that this part here comes out to be a positive number. Okay, so 2x minus 1 greater than or equal to 0. Okay, so that'll guarantee that you'll get a positive number. And then from there, you just want to solve for x. Okay, so if I do that, that's going to give me x is greater than or equal to 1/2. Okay, so this is saying that the only numbers that are going to work in that part of the function have to be greater than or equal to 1/2. All right. So now what we have to do is we need to look at both of the answers that we got and put them together. Okay. So from the denominator, it says that I can't use 5 or negative 2. And then from the radical, it says that all my numbers have to be bigger than 1/2. Right? So if all my numbers have to be bigger than 1/2, x can't be negative 2 isn't going to show up. Okay? Because negative 2 is less than 1/2. So I can actually not even concern myself with that one. Okay? So I just have to be worried about x is greater than or equal to 1/2, and x can't be 5. Okay, so now what we're going to do is we're going to write the domain of g of x. Okay, so it's the set of all real numbers such that x is greater than or equal to 1/2, and x cannot be 5. Okay, so that would be your set notation. And then your interval notation. Okay, so since I'm allowed to use 1/2, I want to include a closed bracket like that. Right, and then I'm going to run into an issue there at 5. So 5 needs to have an open parentheses and then a union going from 5 then to infinity. Okay, so that would be the domain of g of x. Okay, so you just have to look at what you found as an answer and kind of put them together to come up with your final answer. Okay. So example 3, I'm going to call h of x is equal to 2x plus 1 divided by the square root of x squared minus 1. Okay. So again, here I have a rational function and a square root function. Okay, so this is going to be kind of a two-part one. Okay, all right, so let's do the denominator first. All right, so I want to make sure that the square root of x squared minus 1 doesn't come out to be 0. Okay, so to get rid of my square root, right, I would square both sides. Okay, so x squared minus 1 is really x minus 1, x plus 1. So this is saying that x cannot be 1 and x can't be negative 1. Okay, so if I plug those two numbers in, I'm not going to get an answer, or I'm going to get an undefined answer for h of x. Okay, now the other part I have to do is the radical. Okay, so again, I want to make sure that x squared minus 1 comes out to be greater than or equal to 0, right? That's the inside part. Right, now the tricky part about this one is this is what's called a quadratic inequality. So quadratic inequality. Okay, so now you guys might have done some of these in Algebra 2. They're pretty easy as long as you know what the graph looks like. So the best way that we can figure this out is we just need to graph x squared minus 1. Okay, so I'm going to draw my axis here. Now from the first part, I figured out that I have zeros at 1 and negative 1. So I'm going to put them down on the graph. So 1 and negative 1. Okay, and then when I graph my quadratic, I just have to make sure that it goes through those two zeros. Okay, so I'm going to go there and there. Okay, and because it's x squared minus 1, right, that means it's not going to go through the origin, but it's going to go actually through y equals negative 1. Okay, so it's going to look something like this. Okay, so that's what the graph of x squared minus 1 looks like. All right, so to figure out the inequality part is you have to look at the parts of the graph that are positive, right? That are above the x-axis. Okay, so I'm going to highlight them right here, right? So this is above the x-axis, right? And this also is above the x-axis. Okay, so you have to think, okay, which values of x make that possible, right? So if I'm looking at negative 1, right, and the part of the graph that's positive is all the x values less than negative 1, right? So it's x is less than or equal to negative 1, okay? And then it's just the opposite for the other part, right? All the x values greater than 1 are going to make x squared minus 1 positive. So that would be like that, okay? So from just using the radical, I figured out that I'm allowed to use values less than or equal to negative 1 or greater than or equal to 1. Okay? So what we have to do now is we have to put our two answers together, our two domain sets together. Okay? So this is saying that I'm allowed to use less than or equal to negative 1, greater than or equal to 1. But then over here, this is saying that I can't use 1 or negative 1 because then I would get a 0 in the denominator. Okay? So putting the two together, right, that's going to help me eliminate the equal to signs in my inequality. So x has to be less than negative 1 or greater than 1. Okay, so that's putting the two solutions together. All right, so when I write my domain now, I have the set of all real numbers such that x is less than negative 1 or x is greater than 1. Okay, and then interval notation, I'd have negative infinity to negative 1, and then 1 to infinity. Okay, so again, anytime you see a quadratic inside the square root, right, you're going to have to do a little bit of graphing and figure out where it's either positive or negative based off of what the inequality is. Okay, and then the last one I want to look at, we will call this, b of x. So b of x is 9x plus 7 divided by the square root of x minus 2 plus 1. Okay? So again, I see that I have a rational function here. And I also have a square root. Okay? Alright, so what I'm going to do is I'm going to do the square root part first. Alright, so the radical. Alright, so again, what's inside the square root has to be positive. So x minus 2 has to be greater than or equal to 0. Okay, so this tells me that x has to be greater than or equal to positive 2. Okay, and then from the denominator, again, we want to take the entire denominator and make sure that it doesn't come out to be 0. So I have the square root of x minus 2 plus 1 cannot equal 0. Okay, so again, whenever you're doing a rational function, you're going to take the entire denominator, just not the square root part. Okay, the entire denominator. Okay. So again, we want to figure out what value of x is going to make that happen. So I'm going to subtract the 1 over. Okay, so I have square root of x minus 2 cannot equal negative 1. Okay, now in your head, something should be going off right now. Okay, because when you do a square root, right, you're not supposed to be getting a negative number. Okay, so anytime that this happens, this implies that you're going to get a extraneous solution. Okay, and what that means is that you're going to get when you do work out the problem, it's going to tell you that, okay, this is the number that's not going to work. But if you actually plug that number back into the problem, it actually will work. Okay, so it's called an extraneous solution. All right, and what I'm going to do is I'm just going to finish this part, and I'll show you what I mean. Right. So again, to get rid of my square root, right, I'm going to square both sides. So I get x minus 2 can't be 1, and then x cannot be 3. Okay. So if you look at x can't be 3, right? If I plug that back in to my denominator, right, I would get the square root of 3 minus 2, which is 1. Square root of 1 is 1, plus 1 is 2. So obviously I don't get 0 in my denominator. Okay, so I want to actually get rid of this part. Okay, so this 3 actually will work out. Okay, so again, your clue here is when you get a square root equaling a negative, right, that's going to imply an extraneous solution, and that's something that you don't want to include in your domain when you write your answer. Okay, so our final answer for this, the domain for b of x, is the set of all real numbers such that x is greater than or equal to 2. Or we're going to go from 2 to infinity. All right, so those are just a couple different examples finding the domain from a function. So again, if you guys have any questions, feel free to stop by and we can go over some things together.